We're going to take this time to talk through what it means when I say find capital N so that n more than this large N makes this inequality true. As you guys can see, most of the algebra is stuff that we've been through several times. I'm going to do a quick talk through what's happening here and then finish off this video explaining how we find that capital N. And then I might make another short video explaining how when we change this 1 over 100 to the generic epsilon, what that means in terms of actually proving the proposed center of the neighborhood is the limit. But for starters, let's just talk about how this problem is like the ones we've been practicing since early last week. I'm going to read this inequality. I'm going to read this as the statement, things popping out of the sequence, their distance from 2 is less than 1 over 100. Or in other words, the values that pop out of the sequence are always, or at some point between 2 plus a little bit and 2 minus a little bit. My first step is always to take this center, plus or minus that little bit, and put that sequence right in the middle. And then this is all the algebra you might do to try to get that n isolated. I like to, right off the bat, even before I get common denominators, sometimes just multiply through by 100 to cancel them out. You'll notice that that just affects the numerator in the middle. You know, we don't change the denominator at all, obviously. And then the 2 becomes 200. And we're getting down to this place where I need to get this n minus 3 by itself. So we get to here, and I'm going to pause the video and do this math because I'm sure you guys could probably figure it out. If you need to pause and see my work, you can. And I will point out there are other ways to get to the final answer where we're going to have n's isolated that are also correct. So if you have a method you prefer and you get the same answer as me, and if I didn't make any mistakes, then you're fine doing whatever you're doing. But I'm going to pause. So after doing all of this fun work, we do discover that if n's more than 103 and if n's more than negative 97, this original inequality is true. This is something that I think we don't emphasize enough as teachers. When we have you guys solve inequalities, we have you guys get to the end here, and it's all good. We're fine. Like we say, that's the answer. You have it. I have it. Thumbs up. Everyone's happy. But I do think it's important to emphasize when we're saying when this is true, like this being true makes this true. And if this is true, this is true. This being true makes this true, makes this true. If these are both true, this is all true. And if this is all true, all the way back up here, this is true. And I think it's important to understand that chain of like calculations to say that the original goal was to figure out when is this going to happen? When do the terms popping out of the sequence minus 2, when is that less than 1 over 100? Said in a more like less mathematical way, we're saying when are the terms in the sequence within 1/100th of 2? And according to all this math that we did, that happens when both of these things are true. So as far as our capital N is concerned, this is kind of nice that n is bigger than both cases because this is true and this is true basically only when this first one is true, right? If I'm thinking of a number that's both bigger than 103 as well as bigger than negative 97, well, really all I got to do is think about a number that's bigger than 103. Because if it's bigger than 103, it's bigger than negative 97. And that 103, that larger value, will be my capital N. So to say, if we're saying if n is more than 103, then this is true. If n is more than 103, the terms of the sequence are within 1/100th of 2. That's it. That's how you find the capital N. It doesn't prove the limit because the limit has to be for any value, any closeness, and this is just specifically the closest 1 over 100. So if you just worry about how to answer the question, that's how you answer the question. And you say it's n is 103. If you want to understand how we can use this idea to make the proof things better, watch the next video where I just change the 1 over 100 to an epsilon, and I get much more discussing expressions over here. And we talk about how that proves the limit once and for all, no matter what. Yeah, thanks for watching. I hope you guys enjoyed it.